Okay, in 2.5b, we're still talking about regression lines, but now we're going to talk about how do you use those to predict values and to find something called a residual. All right, so here we go. Okay, brief reminder, when the relationship between two quantitative variables is linear, we can use a regression line to model the relationship and make predictions. Okay, and there's the regression line. It describes how a response variable changes as an explanatory variable changes. In that form, it's y hat equals a plus bx. Remember, a is the y-intercept and b is the slope, and we always pronounce that with a y hat. Okay, that's a statistics thing. Okay, so let's look at this. Can we predict the price of a Ford F-150 with 300,000 miles driven? All right, so let's look at the example they gave us first here on the graph, the scatter plot. And you can see there's the regression line right here, okay? And it's 38,257 minus 0.1629x, where x is the miles driven and y is the price, okay? So notice what you do to predict. Okay, we're trying to predict what's the price going to be for 300,000 miles. So all we do is plug that 300,000 miles into the regression equation, all right? So you can do that, and we get a cost of, look, this is weird, negative $10,613. Well, that's completely wrong. We know that, right? Because you can't pay negative for a car. That would just be weird. Well, why does that happen? Well, this is what's called extrapolation. So make sure you know this word. And what extrapolation means is you've used a regression line to predict outside the range of the data. And here's what I mean. If you look at the scatter plot, look at the x values down here. The highest x value they used was up here, like at maybe 130,000 miles. They don't have anything close to 300,000 miles in this data to help you make this line. So because that's not even in the calculation of the line, we can't predict that. It's way outside that, because for all we know, at 300,000 miles, that thing could come right here, and this line could get lower and lower and lower. It could change our slope. Who knows what it could do? All right, or there could be wonky other points in there that's going to change the line. It's going to change the slope, it's going to change the y-intercept, and then ultimately would change our prediction. So because it's extrapolation, it's not a good answer. We would not use it. And here's the definition of extrapolation. Make sure you know it. It's the use of a regression line for prediction far outside the interval of x values used to obtain the line. Such predictions are often not accurate, so we don't use them. All right? So let's look at this. Scatterplot shows a relationship between the number of slices of pizza eaten by each member of the football team, the number of laps around the block the player could run immediately afterward. The equation of the regression line shown is on the graph is, remember this needs a hat on it, 10 minus 0.67x. And this was in our previous video, same example. But here's a new question. It says, predict the number of laps a player who ate 7 slices can run. Okay, slices is my x value. So all I have to do is plug in that 7 into my equation and find out what I get. So when I run those numbers, I get 5.31 laps. Right? So I've predicted and I've shown my work. Okay, I know the calculator's going to do it, but this is the kind of work you got to show me. And yeah, of course you need to have units. Now, B, would you be willing to use the regression line to predict the number of laps a player who ate 15 slices of pizza could run? Let's look at our x values. Okay, does it go all the way out to 15? No. So would we use that regression line to predict something way out here? No. Okay, that would be called extrapolation. So you would say no. 15 slices is outside the scope of the data. Therefore, prediction would be unreliable. Okay? And we would call it extrapolation. Okay? It's a big no-no. So you always have to look carefully at the data to see, can you really use that to predict whatever it is they're asking you to do? Okay, so that's extrapolation. Now let's look at the other concept of residuals. So even when we're not extrapolating, our predictions are seldom perfect. For a specific point, the difference between the actual value of y and the predicted value of y is a residual. Okay, a residual is the difference between actual and predicted. So here's the formula. Write this down. Residual equals the actual y. Okay, this piece of information is going to be given to you in the problem, either in a data table or in the words problem stem. The predicted y, you have to solve for this using the regression line. Okay, so you take the given y and minus the predicted y, and that gives you the residual. Now, what is it we're talking about? Let me just sketch a scatter plot for a second to talk about it. Let's say I have all these points out here, and I have my regression line doing this, right? So a residual is, like, these points don't fall exactly on the line. We know that, right? Some of them fall above, some of them fall below. So they're not perfect. So think of it like this. If it's milk spilled and you took a paper towel and you wiped that middle part right there, okay? All those differences that's left, that's like residue, right? So there's my line again. This distance from the actual points to the line is called the residual. Some of them are above and some of them are below. So what does that mean? Well, that means that for this, a given x value, sometimes the line is going to predict it too high, and sometimes the line is going to predict it too low. Okay? We'll get more into that later, but that's what's happening with a residual. It's all these points that don't fall exactly on the line, and what is the difference between that point and the predicted point? So here's the scatter plot for the Ford F-150, and it shows the residual specifically for an F-150 with 70,583 miles, and the actual price, okay? So here's the actual price of $21,994. The residual is negative. Notice it's negative. Why does that mean? That means the line is predicting it too high, okay? The predicted price, remember we plug it into the equation right here, gives us 26,759. Okay, that's the predicted, but we know the actual price was 21,994. So when we subtracted it right here, we get a negative number. So residuals can be negative. The negative value means that the price of the truck was $47.65 less than predicted, based on the number of miles that it had been driven. It also means that the point is below the regression line on scatterplot. So think about it. If you came up with a positive residual, that point would be above the regression line, and it would be more than what's predicted. Okay, hopefully that makes sense. We'll talk some more about it in class. Let's look at an example. All right, so same example with the pizza and the football players. It says find the residual if a player is able to run 8 laps after eating 12 slices of pizza. So here's my x and here's my y. Okay, this is my actual y that was given to me. So to find my residual, remember it's actual minus predicted. Okay, so my actual is 8, but predicted I have to find by plugging into my equation. So y hat, remember, equals 10 minus 0.67, and I plug in 12. All right? When I do that, I get 1.96. Okay? So it predicted they could only run 1.96 laps, 1.96. And then when I subtract it, I get 6.04. Positive 6.04. So there's my residual, and notice the work that I showed for it. And I have to interpret it. This is the big deal in stats. You've got to interpret it in the context of the problem. So this football player obviously could eat more than we predicted, right? But how much more? 6.04 pieces slice of more, all right? So let's write it out. The football player ran 6.04 more laps than predicted based on the regression line. Okay? Notice the amount of context in my sentence. Notice it's a complete sentence. 6.04 was my residual that I calculated in part C. And I said more because it's positive. If it had been negative, I would have said less than. Okay? So hopefully that gives you some good examples to work with as we work on this in class.